Okay guys, so we've done the first five tasks, so we are moving to the sixth one, though I haven't uploaded most of these guys. So it's the second deadline already and it's just few hours to go. I've been so busy with work because so so let's go to the six tasks, right? So I've opened my this guy and this guy that I've been using to explain rather. So so I'll do ls and let's okay, I think it's delaying a bit, so go to ALX and I think 0x13, right? Yeah, so let me clear, and so far I think we have this, right? So basically the reason why I haven't uploaded the other ones was because there were some issues with checker, so I wasn't sure if it's going to check, so I didn't want to upload something that wouldn't check, right? So it's eventually checked. So basically let's go into it. So this one I'll just run like a marathon, like it's not going to be separate, so I'm going to try and bring them together and do them together. So write a function that deletes the head node of a list, right, and returns the head node's data, right? So what it's saying is so if you have a single linked list like this, it's going to delete this guy, right, and it's going to return the data in it then, right? So that's what we want to do. So I will try and just be short and be fast, so just try and read on your own as well, which would help. Let me just follow the normal protocol. Let me copy this guy. Let me bring this guy down a bit. Sorry guys. So I'll copy this and then I'll view my lists, right, and then I'll paste it there. Okay, all right, so done that, and then I would move to my 6 main.c. Let's go step by step. Okay, paste it there. All right, and then the next thing we're gonna do is create the file, right? So that's what we're gonna do. Yeah, I hope we spend enough time to let me copy this guy. All right, because we're gonna need it. All right, insert mode. Sorry, I went to press nonsense. Okay, good. All right, so first thing I will do is I will include my list .h, and then I will document. So this one will be pop list int delete the first node of a list, right, and return its data. Alright, I hope that guy is not too long. Let me just reduce it. Alright, okay, so we're gonna have a head, which is the pointer to the list. So it enters with a double pointer, meaning that we could modify the head itself. And then we have a return. It's going to return an int. I think we should return 0 or something. So end, and then we're gonna have this. Okay, we're gonna have this. So because we want to return an integer, right, we have int n, right, for the integer, right, we have the data to return, and then we'll have a kind of temporary list, a temporary node, right, to pass in our head sometimes to transverse through the, so let's call this temporary, right. So we'll say that if our head is equal to null, or our, so this head right over here is the actual content inside the, like this guy over here, this 101. Okay, so if inside here is null, that's what we're first checking, and then we'll now see what it is pointing to, if it is null as well, if it's just pointing to this null. Okay, so that's what we're basically doing here. It's equal to null. So if this is the case, then we should just return 0, I guess. Sorry, well, let me just remove that space. Okay, good. So the rule is that if we have just only one line, we can ignore the is it curly braces or the braces anyway. All right, so the block of code, right? So we then say n is equal to, what will be our n, this, right? So we can do like this. So n equals to this, and then so we initialize n to be the data of the, because it is the first node, right? So what we are doing is n is this guy, right? Head next, right? So that is what our head, sorry, not next, head data n, which is our data if you look at the struct, right? So that's what we did. So the next thing is we'll then say our tmp temporary equals to, we'll give it head. Okay, so what we did here is that we created another temporary here and we made it equal to this guy. So that temporary will contain 101, which will point to this address, right? So that's what we did, because we need that if we have to probably change the position of this guy, there's something that we have to have a temporary head that will be holding the list, right? So that's what that guy is meant for. Okay, then because of that, we'll have our head will now equal to we'll now make our head, because we've detached the head now, we've made this one hold this guy, right? So this guy will make it point to this guy, right? That's what we'll do. So we'll make it equals to head and then next, right? So head next. So if you have any questions, always, I've never seen questions like that. Okay, I think I used to see some questions on the comment section, so you can always ask, so we can brainstorm, and I'm very sure you would definitely get your answer. So when you get confused, always ask questions. All right, so the next thing is we've connected it here, right? We connected it to next ptr. What is next ptr? It is 706, which is the address of this guy, right? Okay, that's what we did. Okay, so that's what we did here. So we've connected our head, so our tmp is still holding. So now tmp is just holding this guy, but head is now pointing to this guy, right? So head has been detached from this guy, so it is only tmp that is holding this guy, right? So the next thing we'll do is because we don't need it anymore, we'll free, but we've extracted the data first before we even gave it. So we'll free tmp because we don't need it right anymore. So we have our n, and then we have our, so we can return n, which is what we need, right? So we've detached and then we returned the value, right? So I think that should work. and then what should we do? We then compile, page down. I'm still kind of going to work this morning, but I just had to quickly do this and see deprive this loop. Alright, so we have some errors. Okay, these guys, okay, let me just do it. So vi into, what's it called, 5, right? 5, no, sorry, 6 pop, right? So you said that is a pointer. Do you mean to use this? Yes, that's what I wanted to use now. Okay, anyway, so what really happened is I think I have to just put the brackets and then to make it work. So for these pointers to reference us, the one to referencing, sorry, together, so to show that this guy is together, right? And then this one, okay. So let me clear it and we compile. Okay, we have one more error. Okay, so this guy is supposed to be inside, not outside. How did I make that mistake? Alright, yeah, it's here. Yep, but then it should work this way. So we here, so we have our, I think we can run it. So at the end we had a new. So let me just come there. Yeah, I think we are good, right? Yeah. So let us git add. So I think I can git add everything because I've already ignored G. So git commit, say delete first node of a list and return it data, right? And then I'll git push, and then that will be all, and then I'm good, right? So let's check our code. So it's still almost 2. I'm not sure the checker should give us that much issue till I think 4. Okay, good. So we are good. So let's go to the next one. So the next one says write a function that returns the nth node of a list. That is, we are going to say, okay, I want you to return probably node number 4 or number 3, right? So on node number 1, if it is node number 1, I think it has to start from index 0, and then node number 1 is going to return this node to us, right? Probably the data and the next, depending on what is being specified. Where index is the index of the node. If the node does not exist, return null, right? Okay, so we have all these data. Okay, I think it's going to be the data that is going to return to us. Anyway, you know what to do, right? So we'll copy this guy, or let me copy 7main.c first. Right, so I'll vi my 7main.c. I'll paste this guy, escape, right? Then the next thing I'm going to do is I'll create the file, right? This guy, I'll touch it. I've created the file, then I'll copy this header file. Like this, good. So I'll copy this guy and I'll clear my list and then I'll paste it there. Good. So the next thing I'm going to do is I'm going to VMI 7 gets, right? Good. Insert. Good. Then the next thing I'm going to do is I'm going to include my lists dot h, right? And then I'm gonna get node, right? Integer and index album, right? So this one is to retrieve, right, a node, right? At an index of a list. Anyway, we have our head, right, which is the pointer to the first element, right? First node of first node is okay. Of, let's just say, first element. So the next one is index, right? So what about index, which is the node desired, right, position to retrieve. And then we have our return, because we need to return something. We need to return the pointer to the retrieve node. Alright. Good. So I think you understand what we want to do. So because we have unsigned integer, I can use size underscore t, but let me just use according to what they used. So this would unsigned integer, let's call it unsigned integer, let's say c, or let's say a. Okay, so unsigned integer a. Alright, so we'll say for a is equal to 0, right? As long as a is less than index, because we want to iterate from 0 to the index number, right? Index a plus plus. But I think if you look at this guy perfectly, okay, let's see. Let's still continue. Alright. So the next thing I'm going to do is let's say if our head is equal to null, as usual. If our head equals to null, it should return null, right? It should return null. So I can declare it this way, and then I will say head is equal to head next. Okay, so here our head is then pointed to head next. So this guy is not really the problem. I think this is what we need, right? So at this guy, as far as this thing is concerned, as far as is less than, the head is pointing to the next guy. Okay, so let's say this is what we need. So as far as it has not gotten here, the head will then point to the next one, point to the next one, point to the next one until it gets here. Okay, so this loop will continue, and then this guy will keep increasing, the head will keep increasing, right? So at the end, when it gets to that position of the index we need, then it's going to return the head at that point, right? It's going to return the head at that point, and then that head will be for the desired guy that we need, right? So that's what we'll do, and then we come here, we'll come here, copy this guy, right? Paste it, and that will be all. Sorry, I didn't even check if there's error before checking it. So we have 0 and then 1024. So if you look at it, let's see, 0 and 124. Okay, good. So that's clear. And so we'll git add, we'll git commit. So this one is to it is the guy retrieving, right? So to return the node at a particular index, and then we'll git push it, right? And then clear. Do I have a problem? Okay, good. I thought I have a problem. Alright, so let us check our code. Hopefully it works. Good, praise God, hallelujah. Alright, so the next one, write a function that returns the sum of all the data. Okay, so I think this one would sum up all the data of a list, right? So it will sum up 10, 45, 57 together, right? So all we need to do is just transverse through the name to the list, get all the data, and then add it together, right? We can do sum plus equals to this equals to n, right, of that particular stuff. So there are several ways to solve this. So so let's go through what we did the other time. So we created an 8 main.c, sorry, copy. So create that. We then did what we created the file, touched the file. So this one is sum up, touch the file, right, and then I copied the header file. So this is what I did, and then vi lists, and copy this guy here from the next guy. Good. So this is what I did, and then I went back to my 8 sum, right, and I paste this one here. So I'm going to include my list. There's no issue. List.h. Right, I'm going to document, and this one is sum underscore list integer, right, and then this one will be sum up all the data of the list, right, and then we'll have the bed, which is the pointer to the list, right, and it's going to return this one, right. Did I get my return very well? I think I did. Alright, because it's looking weird. Okay, so that is that on that. So the next thing we're going to do is we're going to declare a sum, obviously. So the next thing is we can initialize sum to be 0 from beginning. Alright, so we'll just say if our head is equal to null, as usual, then we should return 0 because there's nothing to sum when our head is pointing to null, right? So the next thing we'll do is we can use our while loop, alright, and say our head is not, as far as head is not equal to null, so this one will transverse, sorry, null, so this one will transverse through the link. Then what should you do? Then you should do this. Okay, so we'll say sum will equals to what? Sum, you can do sum plus equal to, right? You can do sum plus equal to head and then the reference the end, right? So we are adding this, right? So you can also do sum equals to sum plus head, the reference the get the data, right? And then we can say now head will now be pointing to the next. In order to get that, head will now get to the next. So in order to get the next data, right? So I think that should be that, and then at the end we should return sum. Right? Okay, and I think that should be all. So let's compare. I've not even been betting our work to see, but I think if we have betty issue, compiler will give us problem. It will give us a warning. So we'll copy from here. I think I have included I as well as part of the code to ignore, so we're not pushing that. So when we compare with and I, so we have some equals 1534. Okay, 1534, good. So what we do is, let me git add, and then commit the message and say sum of all the data of a linked list, a single one, right? And then I will push it. Good. So let's check our code to see if it works. So we'll start. Okay, good. Great. So number 9, write a function that inserts a new node at a given position. So what we want to do is we have a node, right, something like this, and then we can insert it at a position, probably position 0, position 1, position 2, right? So that's what we want to do. So the first thing we'll do is we'll create the new list, right? We'll create the new node and then we can insert it anywhere, right? So I'll just do 2 functions for this guy, right? But before that, let's also get our data. So we have our 9main.c, which I'll copy, right? So I'll be my 9main.c, paste this guy there, and then what will I do next? And then page up and page down, and then touch this guy to create it. Then I'll touch this guy. Yeah, there are some updates that I wanted to share that I figured out. Probably I'm gonna make a separate video, but I'm so busy right now, so I don't know. But I think I'll be free on Monday, so I'll use that to create that as much as I can. Alright, so what else do we need? We need the header file, and then like I said, we should have a revision this month. As soon as I can create time, we're gonna have a good revision that's gonna help us a lot. So so let me just do this, and okay, so good. So we have this, right? So I'll just vi my, I think it is 9 words, 9 inserts, right? And I'll put this guy there. Sorry. Okay, and then I'm gonna include my lists dot h. I'm going to document this guy. So what I'm going to do is, for this guy, I'm going to create another I'm going to create another guy. So I'm going to create the what's it called, the new node, right? So to create new node, the prototype for the new node would be it's still going to be list int underscore t, right? So it's going to be a pointer to create new node, and then it's going to pass in an integer n. Okay, so I can just declare it at the top, so no need of adding prototype at the top and then using this guy at the bottom. So I can do that, and then before that I'm going to define it here, right? So I'm going to say this one should create new nodes, right? So this one, it creates a new node, right? And then we're going to add at n, which is the data of the node, and then we're going to have return pointer to the node, right? So let me good. So sorry, I pressed that capital letter mistakenly. So we have our list int underscore t, right? And then we have a new node. So we've created a new node like this, but we have to allocate memory for it, right? So we say new underscore node, right, is equal to what, malloc, and then size of the struct, which has been typed depth. So size of, right, which is list underscore t, right? So list int underscore t, and the end we're going to do like this. So we'll check if the memory allocation is successful, right? So if the new node now is equal to null, then it means the memory allocation is not successful, then it should return null, right? If not, then we can assign the pointer and the data to it. So we assign to our new node, right, to reference it, new node n should then equal to what, the value of n, and then our new node next, right, new node next should then be equals to the value of null. I think we'll initialize it null at first, and then at the end we'll return the head, which is new node. Return new node. No? Okay, good. So we can then let me put space here. We can then work on this one, right, which is the main function we want to create. So I'll do like this, but before that we have to declare this to this guy as well, right? So we want to this, so we'll still have our list integer, right? So we have our list, sorry, insert. So we have to insert node integer at a particular index, right? Okay, so I think the name already said everything about insert a node at an index in a list, right? Good. So the next thing is we're going to declare the head, which is a pointer to the first element of the list. Alright, so we'll also have our index, which is the index to the position the new node is to be inserted. Alright, and then n should be the number to be inserted into the node, right? So at n will be the data of the node created, and we're going to return the address, AWD, I guess, the address of the newly created node. So I think we're done with that. Okay, so done the address of. So if it is not possible to add the new node ID, do not add the new node to the so we're going to have so many lines of code here because we'll be doing so many if not and all this rubbish. So alright, so we have an unsigned int as we have it here, unsigned integer, right? And then I for a loop, right? So we'll have that. We'll have a list int underscore t, a temporary guy that will be the value of head, and then for this one we'll have another list int underscore t, which will be the value of a temporary guy as well that we'll understand when we get to the code. And then we'll need another list int underscore t, and in that one will serve as our new node. Sorry, new node. Okay, so we'll just create, because the reason why I did this separate is because by the time I add this guy to this guy, right, the line will be more than, I think Betty accept, is it 40 or 45? I think 40, so it will be more than 40. Alright, so that's why I just had to create it there. Alright, so the next thing I would do is I would then say tmp. So our temporary now is equal to head, so I've assigned head to temporary, right? So basically what I did here so far is that I just created temporary here and I gave it the address of 101, right? I gave it head, right? So that's what I've done here. Okay, so that's what I did, and then I will say if our head is equal to null, right, is equal to null, then it should return null. So I think this line of code should not be strange to you now, right? So that is, if this guy is pointing to null, it should just return null. Wait, if head, right? Okay, so that is if head itself is null, you should return null. Alright, so if it is the pointer, the star head, it means if the list. So that's that for that. So the next thing is then we'll create our if not, then we'll create our new node. So new node then equals to, then we'll use the create guy to create it. Create new node, create new node, right? And n, because we're going to have a data for it, right? So it's going to accept this n, right? So it's going to put it inside, and then we're going to create a new node. So we'll also check if it is successful or not, right? So if our, I think this one is part of the stuff that we're giving as the success. So if our new node is equal to null, right, that's the data. So if they pass in a invalid data or not, you should just return null, right? And then we are good with that, right? So if our list itself now is equal to null, right? If our list itself is equal to null, then what should we do? Because we have 2 lines of code here, and we need to put on the braces here. So we'll say that it should give our head the value of remember that we want to extract, right? We want to insert. So because it is null directly, right? So it means that we are just going to add is it insertion? Yeah, we're going to insert that new data into the first position, right? Inserting it, yes. So we're going to insert, because there's no, it's not the only position we can insert is going to be position 1, right? So that's what we want to do. So we then pass it the value of it should be new node, not this. We'll pass it the value of new node, right? And then we'll go to the next, and then we'll return new node, right? Because we need to return the pointer to the newly allocated, right? So that would solve that. So that is when there's no content in it already and it's existing, right? So the next thing we'll do is we can come down and say if our index itself is 0, it means we are still adding at position first position, right? So if our index is 0, then our head, our list, right, will still be new underscore node, right? And then that will be that. Okay, so now what if it is not? So we'll have a for loop, and then we'll say our I, we use I equals to 0, right? And then I is, as far as I is less than index minus 1. Okay, so we're going to minus 1 from it, and you get to know why. And then also, so we want to iterate through until we get to this point, right? And then we have tnp, right? Tnp, as far as our temporary, where is our temporary, which is this head, right? Is this 2 space here? Let me just check. Oh, it is. Okay, good. All right. Okay, so and tnp, right, is not equal to no, because tnp is our new head, right? So as far as tnp is not null already, right, and so we're just adding all these guys to it. Index is 0, this guy head is not equal to null, right? So head is already tnp already, so we do that. and then idx, right, is not equal to 0, because if it is equal to 0, it means that these guys would have been done. But I don't think this guys is necessary. I think with this we can stop here. But anyway, let's continue, and then we'll say I plus plus. Good. Then what do we want to do? So if that's the case, then at each point we want to be updating the value of TMP. Should be TMP next, right? So our TMP that is here before, then we point it to the next until you get to that point, right? So we'll do that, and then what we'll do next is, okay, then that will be all, and then we'll say if, okay, if our TMP is now equal to null when it gets to that end part, right? If our TMP is equal to null, it should just return null. And then this one is returning null, is not inserting. Why? Because by the time it is going and then it checked the next data and it is already null, and maybe they said we should insert at position 10 here, and this guy is going and is going, and then it has said that the next is null, it's not an address, it means you cannot get to that position, then we have to return null. Okay, so that's what we do. And then the next thing is let me see. Okay, return null. So we'll say if, let me see, if our index is 0, we've done this before, but if our index is now 0 for this point, we're just gonna new node next equals to TMP. So what we are doing is if it is 0, then equal to 0, not this one is assignment, it's equal to 0. So would pass in this guy, this null, no, this one is null from at the top when we're initializing it, so we are giving it this guy to point to it, right? We are giving it this guy. Okay, so else, so this one would end our code, and then we are going to return at the end, we return our new node. Okay, so what will be inside this else we want to insert. So what we'll do is TMP old, right? We'll hold our value of TMP next, and also we'll have TMP, so we are swapping here, TMP next, we'll hold the value of our new node, and then the last one we have our new node next. New node next will then have the value of our TMP underscore old. So I think with this we should be good. So here we have our TMP old, right? So we are giving the wait. Yeah. Any issue? Okay. So we are giving the value of TMP old, right? TMP old is not holding anything, right? So we are giving TMP next. So if it is not 0, it means it is probably 1 or 2 or something, right? So we are giving that TMP next, right? From here, we are giving it to old, right? Old is holding it, right? So TMP next itself will now equal to new node. So it's now going to have address of new node, right? So and then new node next will now have TMP old, right? Which is, so what we are doing is when it gets to this point, okay, let's say we want to insert here. So the address of this guy, for that this guy is holding, we place it inside TMP old to hold it for us, right? So it's going to hold it so that we can insert this guy and then pass that one that is holding, we'll pass it to this guy. So that's what we are basically doing. Okay, so TMP hold would hold TMP next, right? So maybe it has gotten to the place, let's say you want to insert it. So it's going to hold the address of TMP next, right? This null, right? It's going to hold it, and then we have our TMP next equals to new node. So this guy will now hold the address of the new one we point here, right? And then at the end, our new node next, which is the one that we already have here now, right? Right? Is that it? Yes. Yes, we now have TMP old, which is the address of this guy. Okay, so that is it. So let me bet this guy because we have so many guys inside. Okay, so we have line 46. Line 46. Let me see again. Do not use assignments in, okay, oh sorry, did I use assignments? It's equal to not this. That's not the issue. I thought it said indentation. Thank you. All right. Okay. Let's see. Okay, I think we're good. So let's compile and see. Number 9. So I think we have J already, not to be guy. Hey, any error? Oh, thank God. Okay, so we have 1024 0 to 1024 dash dash 0 to 1024. Great. So we git add, git commit, and say insert a node at a given position. Then I'm gonna push A. Thank God. I thought I pressed enter. Okay. Alright, so let's check our code. Good. So now we'll go to the next one.